In his essay, An Unserious Person's Take on Axiomatic Knowledge in the Era of Foundation Models, Chris Rhee opens the question of whether we need theory or whether pattern matching is enough. Now, of course, I'm simplifying, but in a nutshell, he's also quoting Nancy Cartwright, a philosopher of science, who is opening another door towards the understanding of science in the era of foundation models, and that would be that, well, maybe if we have the luxury of multidimensionality and pattern matching, we might actually not even need a theory. What is an inductive bias? What is a theory, actually? What is an axiom? An axiom is a shortcut towards understanding nature. It's a help. It's a map. It reduces our action space on purpose so we can get stuff done. When Galileo threw the ball or the apple from the Tower of Pisa and then developed a mathematical understanding of gravity, and then later on Newton mathematically fixed all the, crossed all the T's and dotted all the I's, he used mathematics, which is in itself based on axioms, to understand nature. But that opens up a lot of questions and makes it in some way harder to tackle other questions. Axioms are a shortcut that enables us to solve problems, but it's narrowing our dimensionality, our space in which we can actually operate. And Chris opens the door for a multi-dimensionality, pattern matching type science on the basis of foundation models. I think what's really interesting about Chris's approach is that he puts foundation models in a category, I would say, like von Neumann computer architecture. It's a new paradigm. It's not just a tool within the existing paradigm. It's a new way of thinking about compute and particularly thinking about science. So I think we're at a crossroads of something more substantial than just another tool that accelerates compute. I think we are at a crossroads of changing the way we do science and this changing the way we do discovery. This is an Not In Wrong podcast. It's December 3rd, 2024. This is Krim Delko. For the day, the fund is down 1.5%. The market's up 50 basis points. For the year, we are up 68.3%. The market's up 26.3%. We are outperforming by 42%. So Chris Rhee, in his presentation at Stanford, gave a talk in general about research and about what really matters for him personally and what he thinks research should be doing. I think it was an inspiring talk. He talked about the necessity to really tackle difficult problems, but I think more importantly, to look at the world from an angle that might not be obvious and then find new answers. And I think within that spirit, I want to discuss his essay on axiomatic knowledge. So why is he questioning axiomatic knowledge in the first place? Well, because we have foundation models now. What are foundation models? Foundation models are trained in a general way to tackle specific problems. So to quote, in the past, science was, computer science in particular, but science in general, has always been focused on a specific problem and then has used computation to precisely solve that problem. Foundation models are a little bit different. Foundation models train a general model with a lot of data and then try to extract empirical knowledge from that model that is not specifically trained within the training process. So it's an unsupervised learning process. So we look at the world, we store knowledge, we store patterns of knowledge, and then we try to use that for different types of problems. The same applies in robotics, where we've seen foundation models proliferate in the last couple of months, and OpenX and RTX and all these models that came out, particularly here on the West Coast around Berkeley and Stanford, are all focused on the same type of approach, which is how about we train a general model with general data and then apply it to specific tasks. We get more knowledge, we get better performance than if we just specifically train the model on one task. So let me illustrate this with physics and what Chris is trying to tackle here. So we have the Newtonian physics, which are explaining to us how stuff falls from a tree. And we can look at an apple and we can look at a feather. The problem with Newtonian physics comes up when we have turbulences. Lots of different types of wind, lots of different types of influences that start disturbing our system. So we can use differential equations that potentially can help us solve that problem, but it becomes pretty complex. And what he's saying is maybe foundation models with their multidimensionality and their pattern matching ability could actually solve certain physics problems in a much simpler way. And I feel like what these foundation models are doing is almost approximating what quantum computing is promising us. A highly parallel, multidimensional analysis of nature with patterns that we don't even see. And partly we don't see them because we have axiomatic knowledge. Axiomatic knowledge means that we put certain constraints on the actual knowledge that we're trying to evolve because of the axioms, right? We are saying, I don't know, a line is, two parallel lines never cross each other. That's an axiom, which implies that space-time is not curved and, limits our understanding of space-time and so on and so forth. So, but it helps us understand geometry within our classical world. So I think what Chris is up to with his foundation models is really, it is not just reminiscent of what quantum computing is trying to promise us. It is the same thing. We're just coming here from a classical perspective. I think in both cases, what we're trying to do is find the needle in the haystack by removing the haystack. Now, maybe quantum computing can do it faster, but what I think Chris Ree is up to here is really trying to tell us, look, we're really operating in Hilbert space here. We're not operating in human space. Now, the question is, how can we build foundation models that can help us get there? Better foundation models will help us do better science. What are better foundation models? Well, there's two approaches to better foundation models. One is the Chris Ree / OpenAI / Grok / everybody else approach, which is larger models, more parameters, which means more dimensions. The other is, of course, similar but somehow fundamentally different, which is the Richard Sutton approach, plasticity in learning. In both cases, we keep adding dimensionality to the model. We keep adding now. What does it mean to add dimensionality? It just means that we have more degrees of freedom. So we can also discover more things. I think this is fundamental. I think this is a new paradigm. This is a new way of not just doing compute, but thinking about science. And I think his presentation at Neurips 2023, which I discussed already, it was the most important presentation, in my opinion, at Neurips 23, at least keynote, but if not the whole, it was the most important event for me at that conference. It crystallized the idea that we are on the cusp of a new paradigm in science. And the paradigm is to have foundation models with multidimensionality to be able to pattern match against nature and develop knowledge that is not axiomatic. Now, we can then build axioms on top of that, but we have the opportunity here, thanks to the idea of foundation models per se. So, foundation models help us develop not just new compute, but also new science. And I think it's going to go a long way. Now, of course, the engineering path, the actual development of these systems, that has not been solved whatsoever, right? In other words, what kind of hardware, what kind of software, what kind of compilers, what kind of data, in particular, what kind of data. Okay, if I look at physics, my son is working on, let's say, cosmology. He's interested in cosmology, and he wants to tackle dark matter. That's one of his pet projects now in high school. Hopefully, he will be able to continue that work in college and further in grad school. In my opinion, dark matter is a very interesting problem because it literally shows our limits, the limits of our knowledge, right? Because we call it dark because we can't see it. What is dark matter? Sorry for the tangent, but let me explain real quick what dark matter is. There is stuff in the universe, 5% of which we can see. That's the matter that we can see. And then there's 95% of stuff that we can't see, of which about 30% of that stuff is called dark matter, and about 60% is called dark energy. Now, what is dark matter? It's simply stuff that we can't see. Well, how do we know it's there? Because given our mathematics in terms of how celestial objects move around, orbit, and things like that, and given the Newtonian and general relativity mathematics that we use, we infer that there's more matter than we can see. Either that or our models are wrong. Now, in my opinion, this is such a fundamental problem because, not just because, oh gosh, we got to find out what this dark matter thing is. No, I think it's showing us the limits of our knowledge. The same way when black body radiation was a riddle and then opened up a whole new physics, which we call quantum physics today, the same way I think dark matter will open up a whole new physics. Now, we can get to this in several ways, and I think one way is to try to detect dark matter. While we're trying to detect dark matter, I'm sure this is exactly how Max Planck came up with his quantum idea. He tried to analyze black body radiation and then found out that energy is quantized. I think with dark matter, we could, for example, go down the route that we understand that time is very different, and because time's different, cosmological constants are different, and therefore maybe our math is correct, but the constants are just wrong, or the math in itself is wrong. But in both cases, there's certain axioms, assumptions, certain knowledge that we build our whole construct of cosmology on that is probably wrong. And how can we break that band? Well, we can, try to use foundation models to give us more dimensionality, more patterns to match, and then maybe we discover, kind of a Mu 37 in physics, something that humans wouldn't even have come up with. Now, in order to get there, though, we need to have the right data. We need to train our models with the right data, right? The best models are useless if they're not trained properly. And trained properly means having the right data. Now, Chris Ree is working on actually programmatic, data labeling, for example, with Snorkel and other projects. So how can we automate data collection, synthetic data collection? I think all of these projects go towards the same goal, which is how can we better understand nature using the tools that we have, in particular foundation models, which give us the ability to pattern match in higher dimensionality. I think this is really the key that Chris Ree is trying to solve. Now, why is this so important for us here at Orange Capital Partners? Let me just remind listeners, the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. So we're in the money-making business here. And the reason we care about this is we want to understand two things. One is, are we in an AI bubble? And second, if we aren't, how far can this go? The answer is we're not in an AI bubble because this will go very far because this is a new compute paradigm. Every time there's a new compute paradigm, massive new opportunities open up. Could this be a short-term bubble burst? Things like that? Yes, of course. We manage our leverage very carefully for that particular reason. We are very aware of the fact that we could have some sort of dot-com bubble type burst. But even in the dot-com bubble, if you go back to the mid-90s and you look at some of the promises which were made back then, for example, online shopping, online streaming, online media, online travel, whatever, all of these things happen. I think the same way, I paraphrase Mark Andreessen here, almost every idea will happen. The question is only when. This is also even goes back to David Deutsch. Everything that's possible under the laws of physics will actually happen, particularly if it's being tackled by smart people with some good capital behind it. Are we derailed in certain ways? Yes, we've spoken about this at length, that there's a lot of companies. Y Combinator is a waste of talent and companies. companies like Uber and Airbnb and so on and so forth, while they're able to provide certain services as an economic engine, they're useless because they're not really providing any new value. They're not lowering prices. They're not generating new, better jobs. They're just replacing an old system with a slightly better system. The real growth happens when we have, for example, full self-driving with a car, when a car drives itself. The real growth happens when we have agentic programming. So when things like block.new, where you key in what you want and the thing programs everything for you, like that's real massive value creation, and we're going there. And I think what Chris Ree is alluding to is also a new paradigm in science. This is the key. This is what I want to come across here. Now imagine we have a new paradigm in science. Science becomes multidimensional pattern matching. We can discover much faster, much more knowledge, and therefore also not just blow up stuff, in other words, not just develop another atomic bomb. We can get better energy sources, and we can get also much more efficient energy networks. We can get better transportation. We can get better space travel. We can get better software development. We can get more efficient software development. And all these things will lead towards a faster growth and a more wealthy humanity, which is really what we are most interested in here as Orange Capital Partners, not just as money makers, but also from a moral perspective of what our purpose is here as Orange Capital Partners. So to summarize, I find Chris Ree a very inspiring person, one of those people that I would put on my list of professors to pay attention to. That list is Chris Ree, Richard Sutton, Jitendra Malik, Sergey Levin, Drew Batra, just to mention a few. Maybe I should do actually a podcast episode just with sort of my top 10 professors that are worth listening to, worth reading about, worth reading their stuff, things along those lines. But I think what's important here again is new paradigm for compute, massive wealth creation, and that's why we're so excited about AI. Thank you.